This is the main part of the lecture today. Measuring closeness. Okay? We want to actually do this quantitatively. Measuring closeness. So the statement like this means what? Means I can make f of x as close to 10 as I want by making x close enough to 3, right? That's what it means. I can make f of x as close to 10 as I want by making x close enough to 3. See, that's not good enough. Because I want to know, say, if I want to make f of x within 0.1 away from 10, right? So here's 10. What if on the number line I want, I'm sorry. Let's do it here. Here's f of x, here's 10, here's 3. I know that when I'm close to 3, y is close to 10. But what if I want to be more specific? Not only close to 10, but I want to be within 0.1 units away from 10, right? How close does x have to be to 3? Okay, see, we don't know. It depends on the function. Okay? If I want to make f of x within 1/100th of a unit from 10, how close does x have to be to 3 exactly? Right? So that relationship requires some inequalities and some algebra. Okay? And that's all it is. So that's what we want to do. We want to measure closeness. Okay. When we talk about measuring distance, the first thing that we talk about in basic algebra is an expression that looks like this. Absolute value of x minus 2. Absolute value of x minus 2 is the distance between x and 2. If you can remember that, the rest of the talk will be a little easier to listen to. The absolute value of x minus 2 is the distance between x and 2. Right? So that's how we measure distance. That's how, so if I want to say I want x to be close to 2, then that's the same as saying that this quantity has to be close to 0. Does that make sense? So if I want x to be really close to 2, this quantity has to be really close to 0. Is that clear? Okay. Now, if I say that's the distance from x to 2, and I say the absolute value of x minus 2 is less than 1, then what is the translation of that in words? Right, no, the meaning of it. I don't want an algebraic statement. X is at most 1 unit away from 2. That's what it means. Okay? X is at most 1 unit away from 2. Okay? If x is 5, how far is it away from 2? 3 units away. So will that be in this space? No. If x is 2.2, how far is it away from 2? Is it in this space? Yes. Yes. At most 1 unit away means I can live here or I can live here. This is where x is. That's what this means. x is at most 1 unit away. This is the distance, right? At most 1 unit away from 2.
It could be less than 1.
Yeah, at most 1. So it could be half a unit away, could be a quarter away, right? At most 1 unit away from 2.
It can't
Okay.
be less than 1.
I'm sorry?
No, it can't be 1. It has to be between 1 and 2.
Between 1 and 3.
Aaron,
X can be between 1 and 3, at most 1 unit away. Okay? And that really is what the algebra is about, right? In algebra, what do we say to this? We say this, correct? And then we say add 2. Okay. Of course, x is between 1 and 3. Because this means x is at most 1 unit away from 2. That's how you should think about it, in terms of pictures. Okay? Is that clear?
yes.
All right. Let me just ask you this question. What is the meaning of this?
X is right most.
Maybe writing it this way is easier. How would we say that?
Half a unit away from -4.
Very good. That means x is at most half a unit away from -4. That means it's around -4. Half a unit this way and half a unit this way, at most. That's where x lives. Okay? So already we're talking about how to measure closeness, right? If I say x needs to be close to 4, we're how close? Then you say, well, about half a unit away at most. Right? If I want to say I want x to be even closer to -4, then maybe I'll say something like this. That's even closer to to -4. Does that make sense? This is the language we want to speak in order to do this closeness and measurement stuff quickly. Okay? If you can translate between absolute value statements and ideas about the distance and closeness, then we can move forward. Okay. Let's go back to the informal definition and now formalize it. Okay, this means f of x can be made arbitrarily close. In other words, it can be made as close as we want. To L. F of x can be made as close to L as we want. All we have to do is do what? By making what? X close enough to C. Okay? This is still the informal definition, but now that we have this new language of absolute values, let's translate it to this new language. Okay? F of x can be made as close to L. So we're talking about the distance between f of x and L. What absolute value did that translate to? F of x minus L. Okay? This can be made as close to this as you want. That means this quantity can be less than anything. Right? Okay, anything, well, anything positive. Right? Because distance can't be negative. But so you can make this as small as you want. In other words, less than anything you want. Is that clear? By making Okay, now translate this. By making x close enough to c. Talking about the distance between x and c. Translate that. By making this quantity less than something good enough. Okay? Let me write it over here. This statement says f of x minus L can be less than anything. Right? And this sentence says by making this, small enough. Okay? So, the only way I can control this is by controlling this. Okay? Does that make sense? Okay, if I want to make f close to L, I have to move x close to c. So this is what I control, and that in turn controls this. You with me? Okay. So how close I make x to c depends on how close you want f to be to L. Okay? So like I said earlier, tell me how close you want this to be to L, and I'll tell you what you need to do to x, how close you need to make it to c. Okay? If you can do that for any number up here, if you can find out what this should be for any number up here, then you have a limit. Because the definition said as close as we want, which means I should be able to give you any number here, and you'll give me a good number here that will satisfy that. Okay? And that's the formal definition of a limit. And I'll write that down now. Well, maybe I should do an example with